Hey, how you doing, guys? It's Belly here. I do code and stuff on YouTube. Check the description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel. Give me a big thumbs up to support it. And this is called K closest points to origin. We have a list of points on the plane. Find the K closest points to the origin 0, 0. Here, the distance between 2 points on a plane is the Euclidean distance. You may return the answer in any order. The answer is guaranteed to be unique except for the order that it is in. For example, we have 2D array 1, 3 minus 2, 2. K is equal to 1, so we just return minus 2, 2. The distance between 1 and 3, and the origin is square root of 10. The distance between minus 2, 2, and the origin is square root of 8. Since square root of 8 is less than the square root of 10, then minus 2, 2 is closer to the origin. We only want the closest K, which is equal to 1 points from the origin, so the answer is just minus 2, 2. Here the same, but the answer in different order, it would also be accepted. You can check this out as well if you want. Well, we can solve this problem using just a quick sort. You know, guys, we pick up a pivot, and then after the first iteration, the elements on the left hand side are less than pivot, and the elements on the right hand side are bigger than pivot. That's how that works. Well, go for it. I'll tell you how to do that. First, we need to set up a few variables. Int the left pointer equals to 0 and right pointer equals to points dot length -1. Next, we create a while loop. While left pointer is less than or equals to the right one, int middle pointer equals to, we create the helper method, and right here we pass points, and we pass also the left pointer and the right one. We can say private int helper int points and left pointer and int the right pointer respectively. Finally, just return, we return something, right? So right here we check in the case when the middle pointer equals to K, then we break out of this loop and we return arrays dot copy of range. We pass points to the array and we return the copy in the range between 0 and K, because at this point of time the values are already been modified, right? So we just return this range. Otherwise, we need to set up 2 more conditions. Else if in the case when middle is greater than k, we should say the left pointer equals to middle plus 1, and otherwise, in the case when middle is less than k, then we say oh, right here, by the way, right here we need to say minus. We say no, right here, let's say middle is less than k, then we say middle plus 1, and in the case when middle pointer is greater than k, then we say the right pointer equals to middle minus 1. That's it. Yeah. Next, right here we create just pivot equals to points at the position of the left pointer, and while the left pointer is less than the right one, we create if condition if left pointer is less than the right pointer, and also we should create another helper method. It's called compare. We compare points at the position of the right pointer and pivot. And in the case when this value is greater than or equals to 0, we just need to decrement the right pointer by 1. And as you know, guys, like we need to implement the method compare. So right here we pass array row A and row B. So we return A 0 multiplied by A at the position of 0 plus A at the position of 1 multiplied by A at the position of 1 minus B at the position of 0 multiplied by B at the position of 0 minus B at the position of 1 and multiplied by B at the position of 1 as well. We do this because, as you know from the description of this problem, we need to just pick up the bigger row, right? And in the case when this right here row is bigger, then we need to decrement the right pointer by 1. We just decrement, one pointer, right pointer by 1, and if it's not, then we just skip this step. And also we need to say points at the position of the left pointer equals to points and the position of the right one. And in the case when the left pointer is less than the right pointer, and also compare points at the position of the left pointer, and right here we pass pivot is less than or equals to 0, we increment the left pointer by 1. And also points at the right pointer equals to points the left pointer. Finally, we just say points at the left pointer equals to pivot, and finally we return the left pointer. That's it. That's the whole problem. Let me check real quick any typos or whatever. Just right here we say okay, and here if it's so, then we break out of this loop. We create this condition. If middle is less than k, then middle plus 1 or minus 1, then array's copy of range. We construct an array and we just return the array in this range, within this range. And right here we say points left and right pivot. Yeah, that's right. Let's run this code. We'll see how that works. Accepted. Great. Let's submit. First try. There we go. Good. So we just use quick sort to solve this problem. So that's pretty obvious, right? What we are doing here. First we calculate the pivot right here, right? And we just try to pick up the maximum element to your left, which is less than or equals to the pivot, right? So if the left pointer equals to the pivot, right? I mean, I would say k minus the left pointer equals to the pivot, right? So in this case we return this left pointer. We don't want to return the element, like all elements to your left are adequate, right? But we need to maximize this element, like this pointer, right to the pivot. And we do that on the left hand side, and then we do the same on the right hand side. That's how that works. Yeah, and this right here, this method is used to pick up also the biggest the bigger row points at R or pivot, this right here, or just points at left and pivot right here, right? That's it. Thank you guys for watching. Leave your comments below. I want to know what you think. Subscribe to the channel, give me a big thumbs up to support it, as I said right off the bat, and follow me on social medias, on Instagram, on Snapchat, and I wish you a good luck. Thank you. Bye.